Welcome to Study Loop.
Okay, so problem number 57 states that for a small amplitudes of oscillation, the motion of a pendulum is simple harmonic. For a pendulum with a period of 0.500 seconds, find the ground level energy and the energy difference between adjacent energy levels. Express the results in volts. Are these values detectable? All right, so let's start off with what we know. So we know that the period of the pendulum is, so T is equal to 0.500 seconds. And so the first thing is the energy levels of a harmonic oscillator are given by n plus 1/2 h bar omega. So for the ground state, E sub 0 is equal to 1/2 h bar omega. So omega is equal to 2 pi divided by the period, which is equal to 2 pi divided by 0.500 seconds, which is equal to 4 pi. Now 2 divided by 1/2, 2 times 2, hertz, or inverse seconds. So now E0 is equal to 1/2 h bar omega, which is equal to h over 4 pi times 4 pi inverse seconds. Now, if you see what I did here, h bar is equal to h over 2 pi. So I just plugged in h over 2 pi for h bar, so that allows this. And now you get the energy of the ground state is equal to 6.6, just Planck's constant, 6.626 times 10 to the minus 34 joules. Now to convert this to EV, so E0 is equal to 6.626 times 10. Here, let me fix that. Sometimes. So E0 is equal to 6.626 times 10 to the minus 34 joules times 1 EV divided by 1.6 times 10 to the minus 19 joules, because you have 1 EV is equal to 1.6 times 10 to the minus 19 joules. So you use this conversion factor. This gives you that the total energy is equal to 4.14 times 10 to the minus 15 electron volts. So now we need to find the energy difference between adjacent levels. We look back at the energy. I'm going to create a new page here. We look back at the energy for a harmonic oscillator between levels. So E sub n is equal to n plus 1/2 times h bar omega. So, and e to the n plus 1 is equal to n plus 1 plus 1/2 h bar omega. So now the difference between the two, delta E, is equal to e to the n plus 1 minus e to the n, which is equal to n plus 1 plus 1/2 h bar omega minus n plus 1/2 h bar omega. All right, so which is equal to h bar omega times n plus 1 plus 1/2 minus n minus 1/2. Okay, these cancel. These cancel. You end up with just h bar omega. So that's the energy between adjacent levels in a harmonic oscillator. So which is equal to 2 times the ground state energy. To E0. There we go. We can calculate this energy difference in joules and electron volts. So delta E is equal to 2 E0, which is equal to 2 times 6.626 times 10 to the minus 34 joule seconds, which is equal to 1.33 times 10 to the minus 33 joules, or in electron volts, 1.4 times 10 to the minus 15 electron volts is equal to 8.30 times 10 to the minus 15 electron volts. So to answer the final question, are these values detectable? No. This is beyond the limits. Maybe with the most sensitive techniques possible, you might be able to measure energy levels this low, but in practicality, no, these are not detectable energy levels.